Hello everyone, my name is Josip, I'm the head of solutions at Memgraph, and today I'm going to show you how you can analyze your insurance dataset with the help of Memgraph database and a little bit of help from Memgraph Lab, our UI visualization tool. So let's connect to our Memgraph. I have already imported here a dataset of insurance. As we can see, it has 8.5k of nodes and 12k of edges. Here's the congestion used on Memgraph side, and you can get this dataset here. It's in the vehicle insurance data, but I'm not going to load it again. So as we can see here, if we spread out a bit the graph schema, you can see a bit what happens with our insurance dataset, and everything resolves from this claim. We have a claim ID, and some of the claims can be actually fraudulent, and we'll want to actually look up which of the incoming claims are fraudulent, so we can save some time from the domain experts from executing some menial work. A claim happened because there was an incident and an individual was involved in an incident. An individual has suffered an injury, an individual has a policy on the vehicle, the individual also has an address, and the incident can be on an address, and we have an additional claim payment that's for the claim. So actually we can analyze this dataset on multiple ways, but mostly people want to have the insurance data visualized in a graph way because that enables them to analyze the highly connected data, and because there are more than one variable at one at a time that one needs to look at in order to figure out what's going on, and that's usually time-consuming work and mind-consuming work and that's all sort of stuff. And we want to actually employ more advanced techniques like algorithms and traversals on graphs to actually make sure that the claims that people are filing are not fraudulent. For example, more people on the same address can be involved in a claim. That makes it maybe more fraudulent in some cases if that action repeats, and so on and so forth. Here I'll be using my query collection. This is kind of a library of queries which you can show to your peers and colleagues, so please check the collections in Memgraph Lab. And now we can see what we can do with our data set. And this is actually basic pattern matching with Memgraph, with Cypher, the query language of graphs, and we can actually see here if we get the results, which individuals have actually the most number of policies. So that can be sort of one query which we can execute, but we don't need to use one query. We can use like an ensemble of queries and therefore investigate more on the case. So ordering claims by matched claim payment amounts, that's certainly one valuable factor that we can look at and actually see which claims are actually have the most sum of money. That can certainly be suspicious. When we are talking about claims, we are more interested in false negatives to be as minimal as possible, and that's like ideal 0, because if the system says something is not a fraud when exactly it is, then we won't process it. But what we are happy with are actually false positives when we say it is a fraud and we process it and it's actually not a fraud, because like system is still like alert and it's giving us new claims, and although their system might sometimes forget that or actually do a wrong assumption that something is a fraud when it isn't, it still like has a high possibility because of the chance factor. So third query, count the number of individuals involved in a claim. How many actually individuals was involved in this claim with this ID? So we get the count of 3. This is still basic pattern matching. So we have Memgraph is actually, because of its in-memory architecture and it's built in C++, it's really well suited for pattern matching. So we can actually do deep path traversals and actually see the whole subgraph of people who are involved in this case, leading to a fraudulent claim. And if we run this query, we get actually the multiple subgraphs of it. Actually, we can style even this, and I have prepared um, GSS style or graph style sheet style, and it's, I think, this one. And then if we can, it's actually easier to analyze for people who are domain experts, because it's actually tells them, okay, which is which. So we have a claim on a policy, linked individual, incident, and this claim is obviously fraudulent. So yeah, if we click on these nodes, we get extra information on that, and that certainly helps domain experts analyze things in a graph way. So basically, and if we actually do, let's say, a neighborhood search, we can use some of the algorithms which are specific to Memgraph, and that's namely like BFS, DFS, weighted shortest paths, and they're all embedded in Memgraph, and that makes Memgraph actually a great choice for deep path traversals, because we have it all in Cypher. We can even filter inline based on these algorithms, these queries. But let's see if we have a claim, can we actually lead to a fraudulent claim that's true, and we see actually we have, based on the neighborhood of all the claims, we can have one claim that's fraudulent. So yeah, then if we see this claim and see it's okay, it's not far away from a claim that's fraudulent, then that means this one should be actually investigated, and that it might need some further processing, because it's suspicious that it's so close to the fraudulent claim. So yeah, but what we want to do with this, before we actually go to the top point of this video, we can actually show you the built-in Memgraph algorithms. Now let me just zoom in a bit. And yeah, basically what you can do with these algorithms is actually do whatever of these algorithms you want. So BFS, DFS, with the shortest path, all shortest path, and you can you can use them to actually query your graph and filter based during the path traversals to get the most accurate results. For example, you can use this syntax right here, which is actually filtering inline the deep path traversal, and even go more granular than it, filtering the already on the paths that you're already expanding on, and actually get to the point where you retrieve what you actually need, and you don't need any pre-processing, post-processing in your application level. So yeah, after we saw that this maybe BFS is a pretty cool query we can use, because it analyzes the whole neighborhood and sees what claims are close to each other, we can create a trigger which will actually update on creation of the vertex. So this is actually the trigger specification, and on a vertex create we will actually execute the BFS and mark any vertex that's close enough to a claim that's fraudulent as suspicious, which will then trigger a notification to some of our maybe domain experts. Will be able to analyze then the graph and see what's happening, and actually bring the verdict of is something fraudulent or not. So yeah, if we run this query, we have created a trigger, and now basically we will create a claim with this amount, with this ID. It's dummy ID, so we can track it and see what happens. So this individual ID is probably some fraudulent individual ID, so we can actually mark it with a trigger. And after running this query, and I'm not sure why this happens sometime with Memgraph Lab, but yeah, it's I think it needs to go another time. But yeah, basically we have created two nodes, so one incident and one claim for an incident, and then our trigger should have actually said something. And here in this claim suspicious true, if there is any suspicious nodes, our graph would need to have been updated, and that's true. We have one suspicious node, and Memgraph has analyzed everything in real time based on its triggers, and we have got ourselves a suspicious claim with this ID, which was the one that we created, this amount. And yeah, after the analysis by domain experts, we can actually see what's happening here, and whether we mark it really as fraudulent or not. So yeah, but that's basically it. We have here seen how we can do pattern matching with Memgraph. We can see we have seen how we could analyze using these inline path traversals with Memgraph. Also, there's some other cool stuff like query modules, streams, whatever, what we didn't cover, but you can check that on our documentation pages and best practices. Yeah, so basically this has been everything with fraud detection. Hope you learned something, and see you next time in the next tutorial. Thank you.